We had a question come in about how to model mixed number multiplication using an area model, and this fits under the standard for 5th grade operations with fractions, where we are applying and extending our previous understanding of multiplication and division. So if we think about how we multiplied in our earlier grades, we would think about partitioning and iterating multiple times, or we'd have that repeated addition. So in this particular case, we have to build something that will be iterated, or we have to build something that will create dimensions of a rectangle so that we can find its area. What's critical to this is figuring out what our unit of 1 is. And we get a clue about what our unit of 1 is by looking at the denominators of the numbers involved in the problem. In this case, we need our 1 to be divisible by 3, and we also need our 1 to be divisible by 2. That means our unit of 1 should be divisible by both or by 6. So the smallest unit of 1 that I can build would have 6 pieces. Now, if I want to extend this to an area model, that means I need to have not only a unit of 1 on the base, but I also need a unit of 1 on the side. So a unit of 1 would actually look like this when we're dealing with area. So if we're going to model this multiplication problem using area, then we're going to have to be looking for how many of these units show up in our final structure. So first we're going to build one dimension that is 2 1/3 linear units long. That means I iterate this piece 2 1/3 times. So here I've got 1, 2, and then I take a third of this unit of 1 and I get the third piece to add on. So this would be the base of my rectangle. The width of my rectangle is going to be 1 1/2 of these units. So here I have 1 unit and then half of that unit. This now will make the height of my rectangle. So if I want to fill this entire rectangle up, and as I'm doing it, I want to be thinking about how many units of 1, or how many of these big white flats are going to fit. So here, just to reorient, we have one dimension that is 1, 2 1/3, and we have another dimension that is 1 1/2. And the question is, how many of these big flats of unit 1 fit in this entire shape? Well, we can see we have one here, and then we have another one here, and then we've got these leftovers. So I'm going to pull this to the side for just a second so we can look at our leftovers. If I put these two together, I've built another one. So now I have 1, 2, 3 of those units of 1, and then I also have this piece over here, which if we rearrange them, we can see that we can build another half of that unit. So putting them all together, we end up with 3, 1, 2, 3, and a half units.